All right, today we are doing section 7.2, day 2. So we are going to continue multiplying with radicals, and we are also going to talk about dividing radical expressions. I believe there was some like this in the homework, but we didn't specifically talk about how to do them. So you can handle it a couple different ways. What I like to do is multiply them together first and then simplify, kind of like our instructions say. We're going to multiply first and then we'll talk about simplifying. When we multiply these together, you can handle it a couple different ways. What I like to do is show it all underneath a radical together first. So x squared times x cubed, and I like to rearrange it so that like things are by each other. Y cubed, y to the fourth. So notice I just rewrote it all. It's all getting multiplied together under one big cube root, but I didn't actually combine anything just yet. If you wanted to combine your numbers, like multiply them together, you can do that. Multiply the variables together, you can do that. When we multiply two of the same variable, what do we do with their exponents? Add them. Okay, so that would be like x to the 5th and y to the 7th. Okay, so that is something we should already know how to do. But then after that, we start simplifying it. So I don't know that it's necessary for us to rewrite everything just to have to rewrite it differently again. So if we are breaking up the 54, what can we break it into? 9 and 6. 9 breaks into 3 and 3. 6, 3 and 2. Is the 5 going to break into anything? No. No, so it just stays a 5. But we can't forget about it. We still have a 5 there. What are we looking for groups of? 3. Groups of 3. Our index on the outside tells us we need 3 of something for it to simplify. What do we have a group of 3 of? 3s. What's alone? 3. The 2 and the 5 up there. So when we start building our answer, we would have what on the outside? A 3. And on the inside? A what?
15. Oh, 2, 10.
Oh, whoa, a 10.
10.
Okay, I would agree with a 10. I'm going to scoot this over just a little bit. Okay, because we had the 2 and the 5. 2 times 5 gets us back up to 10. Notice that I left a little space outside and some space inside for my variables. Next, we go to the x's. Again, we're looking for groups of 3. If you need to write out all 5 of your x's, you can do that. 1, 2, 3, 4, 5. You don't have to, but we're looking for groups of 3. How many groups of 3 do we have? What? 1 group of 3, and how many left over? 2. If we have 1 group of 3, how many x's can I write outside? 1. Just 1 group, 1 x. We had 2 left over. Where do those get put? On the inside. So we have x squared. We okay with that? Next, we move on to our y's. Again, if you want to write out your y's, all written out, how many y's would we have? 7 of them. All of them. 1, 2, 3, 4, 5, 6, 7. How many groups of 3 do we have? 2. We got a group here. We have a group there. So on the outside, I could write y squared for 2 groups. And how many y's are inside? 1. If you don't have to write out your x's and your y's like that to be able to see the groups and how it should work, you don't have to do that. But if you're a little unsure, not very confident yet, still getting used to it, go ahead and write it out. It doesn't take very long. You can pretty much guarantee you're going to get the right answer. Okay, questions about example 1. Did we do these in our homework last night when we saw them? Because we all did our homework like good students. Are we ready for number 2? Okay. I didn't hear a whole lot of people confidently saying, yes, I did my homework like a good student. Makes me a little nervous for you. On example 2, what kind of root are we taking? A square root. So when we look for groups, we need groups of 2. Okay, now what might be different about this problem from yesterday is what? The number's outside. Okay, the index is not written, right? But we just discussed that we're looking for groups of 2. The index is never there on a square root. All right, when we have numbers on the outside of radicals, they automatically get multiplied together. And they will also get multiplied to any other numbers that we do end up bringing outside the radical. So treat the outside separate from the inside. On the outside, for right now, we've got 3 times 2, which is 6. Underneath, I am going to leave it kind of split up for right now. If you want to write them combined, you can. Okay, but for now, I'm just going to leave them split up. I think it's most helpful to leave them split up when we're working with the numbers, right? Because if we multiplied them back together, the first thing I'm going to ask you to do is to then factor it and break it back apart. So let's deal with the numbers inside first. Will 7 break down?
No.
Will 21 break down? Into?
11, 2.
No.
7 and 3.
7 and 3 I like a little bit better.
Oh.
So do we end up with a pair of anything? Sevens. This 7 up here still counts. So we now have a pair of 7s. Pair of 7s. What's alone?
3.
The 3. So let's start building our answer. On the outside, we already have a 6. What else is going to come outside?
7.
A 7.
And 3. Or X.
We're not even to the X yet. You're getting ahead of us. Underneath the radical right now, I would have...
X to the 3.
Nope. Well, we're building our answer. What's staying underneath the radical from what we've done so far? Okay. Goodness. Now, the part Jacob's been looking forward to, we're ready to talk about the x's. If we were to combine these, how many x's do we have all together? 6 x's, and we're looking for groups of?
2.
How many groups of 2 do we have?
3.
3 groups of 2.
4, 6.
So on the outside, we could write x to the 3rd power. And how many x's would we have left over? None. So we don't put any on the inside. Are we okay with that?
Yes.
If you need to, write out all 6 of your x's and circle them in groups of 2. 1, 2, 3. All right, the last thing we have to deal with is the y. We've got y squared. What's the square root of y squared? Just y. Okay, again, if you want to write it out, you got 2 of them. That makes a group. 1 comes out. Do we have any underneath? No. So there's our, well, there's almost our answer. What do we still need to do?
7.
42.
Okay, 6 times 7 is 42. X cubed, y, square root of 3. There is our final answer. On this one, we already talked about a little bit that we're looking for groups of 3. Okay, so if we were to write it all together, one big happy family, we'd have 25 times 5. Let's go ahead and write our variables singly with just one exponent so we can see what that would look like. If I'm combining x with x to the 4th, I would have a total of x to the 5th. Y to the 8th times y cubed. is y to the 11th. So if you prefer to write your x's and y's put together, that's fine. Even if you prefer to write this as one big number, that's fine. I just don't like to, because the first thing that I then have to do is break that number back apart. 25 factors into 5 and 5. So I have a group of 3 5s. 1, 2, 3 5s. So when I start to build my answer, on the outside I have a 5. Leave a little space. Underneath the cube root, do I still have a number? No, no big number underneath anymore. X to the 5th. How many groups of 3 do we have? One group of 3. And how many left over? 2. So x on the outside for that one group, x squared on the inside for the leftovers. Y to the 11th. How many groups of 3? 3. So y cubed for those 3 groups. How many left over? 2. So y squared underneath. Do we have questions about it? Jacob?
So if there's 11,
Mm-hmm.
11 y's, that would be 3, 6, 9.
Mm-hmm.
With 10, 11, 12, 3 left, right?
Why are you going up to 12? Now, it's not polite to laugh.
That's why I'm getting confused.
Okay. Because if you went all the way up to 12, you would make another group of 3.
Yeah.
Okay, so that's why we stop at 11.
I don't know why. I don't know how I get confused.
It's okay. Any other questions? Okay, ready to move on? Today's new property is the dividing radical expressions property. If the nth root of a and the nth root of b are real numbers and b does not equal 0, then the nth root of a divided by the nth root of b is equal to the nth root of a divided by b. So just like when we're multiplying radicals, if we divide radicals that are the same type of root, meaning like they have to both be square roots or both be cubed roots, then you can either write them split up, top and bottom, with their own radical symbols, or you can write them smushed together, like a big division problem with one big radical over it. First example with this property, we have the cube root of 32 over the cube root of -4. Now in this case, technically we could start simplifying the numerator if we wanted to, but what's going to be easier for us is if we take one big cubed root right away of 32 divided by -4. Over time, hopefully you'll learn the best way to start simplifying these, but looking at this problem, I should be able to tell right away that I can take 32 and divide it nicely by -4. What does that give me? A -8. So now this all of a sudden is the cube root of -8. Which I'm hoping some of you are becoming more familiar with your perfect cube roots. Not 2. Good, -2. We can take the cube root of a negative number. So this comes out to equal -2. Questions about example 4? We all get it copied down because it's going to disappear when we put up number 5. Okay. All right, number 5. Again, I would recommend smushing these together first, simplifying under the radical, and then seeing if we can continue to simplify. So 162x to the 5th divided by 3x squared. And we're taking the cube root of all of that. So first, we're just going to leave the cube root there and simplify underneath. What is 162 divided by 3? 54. Does anybody remember how we take x to the 5th divided by x squared? Subtract the exponents. Very good. So we end up with x cubed. And now we're simplifying this just like we were doing last week, yesterday, earlier in this lesson. 54 is not a perfect cube number, so we have to break it down. What can we break 54 into? 9 and 6. 9 breaks into 6. Okay, I'm looking for groups of 3 because that's my index. What do I have a group of 3 of? And what's alone? So we start building our answer. What's on the outside? 3. And on the inside? 2. Okay, if we have 3 x's, that just makes one group of 3. So x comes outside. Any x's underneath? Nope, because there were none left over. And that is our answer. 3x times the cube root of 2. This time we are taking square roots. So we are going to write one big square root sign. And then we are going to have 12x to the 4th over 3x underneath our square root symbol. Simplify underneath the square root symbol first. 12 divided by 3 is 4. X to the 4th divided by x?
X cubed.
Good, x cubed. Remember, we treat this like an exponent of 1. 4 minus 1 is 3. What is the square root of 4? 2. How many groups of 2 do we have inside of 3? 1. With how many left over?
1.
So 2x times the square root of x is our final answer. Okay, we got a few more notes. Sometimes radicands are not evenly divisible. If this happens, then you must rationalize the denominator to remove the radical sign from the denominator. Okay, I believe this is continued on the back side to rationalize. To rationalize, multiply both the numerator and denominator by the radical expression that would make the denominator a perfect root. After we do all that, we always simplify completely. All right. On number 7. My favorite ones to rationalize are square roots because it's honestly the easiest one to rationalize. We have to multiply the top and the bottom by the same thing. That's important to remember. Top and bottom have to get multiplied by the same thing. And we want to multiply by whatever is going to make the denominator into a perfect root. Now, I said I like square roots the most because in order to turn the denominator into a perfect square, you just have to multiply it by itself. Because if it has a pair just like it, that is going to force it to be a perfect square root. That is not always the case when we have other types of roots. Multiply the top and the bottom by the exact same thing. Okay, 3 times 3 is going to give us 9, and we know the square root of 9 is 3. In the numerator, we take the square root of 2 times the square root of 3, we get 6. Do we have any pairs? No. So what symbol do we still need? The square root. Okay, nothing is simplifying that is not a perfect square number in the top. So we still have to put a square root in the top. We just don't need it in the bottom anymore. Do you think I can reduce the 6 and the 3?
Yes. 1, 2, 3.
Answer is going to be no. Why not? The square root sign. The square root of 6 and 6 are two very different numbers. The square root of 6 is not going to be divisible by 3. Okay, so do not get tricked into thinking that you can simplify that anymore. Questions about number 7? Are we sure? Okay, are we ready for 8? Okay. Number 8. Now again, what kind of root are we taking? A square root. So in order to rationalize, we multiply the top and the bottom by the exact same thing. If you're trying to rationalize a square root, your life is a little bit easier because you can just multiply by exactly whatever the radical already is to double it and turn it into a perfect square root. Top and bottom, got to get multiplied by the same thing. So I'll continue it off to the side here below. In my numerator, if I'm taking x cubed times 5xy under a square root.
5x to the 4th y.
Good. 5x to the 4th y. And in my denominator,
25x squared y squared.
okay, so we're taking the square root of 25x squared y squared. All of those are perfect squares though. What's the square root of 25?
5.
Square root of x squared. Square root of y squared. Okay, do we notice anything about my denominator here and my denominators up here? It's the same without
Square root.
the radical. Okay, so if you multiply two identical radicals together, you're going to get whatever was underneath the radical without a radical anymore. Does that make sense? If you need to write it out in multiple steps, that's fine. But with a square root, that's how it'll always happen. But we can still simplify this just a little bit. In our numerator, what can simplify?
The x.
The x. What's the square root of x to the 4th?
2.
X squared. Right, we got two groups of 2. So x squared times the square root of 5y all over 5xy. But now what can simplify? Top and bottom. The x's. They're both outside of a radical. So x squared over x simplifies to just be x. So it goes away from the denominator and drops a degree in the numerator. So we end up with x square root 5y all divided by 5y. And that is our final answer. Are we all okay with how I got the 5xy in the denominator? If you want to write that other step out, it's totally fine. You can do that. I'll write it over here. X to the 4th y. In our denominator, it would have been square root 25 x squared y squared. If it helps you to see that step, go ahead and write it. It doesn't hurt anything. It just doesn't have to be there. Okay, we'll go ahead and put them all up there. I might have to cover some of them up one at a time while we're working through these. On number 9, we've got it written with one big cube root sign. But can we simplify 2 over 3x? No. So this is when we're going to go the other way and split it up. So the cube root of 2 over the cube root of 3x. I am going to cover up number 10 for now so that I've got some space to work, but I'll bring it back in a minute. Now, with square roots, it was easy to force the denominator to be a perfect square root. With cube roots, it's a little bit trickier. If we multiply 3 times 3, is that a perfect cube? No. So now, instead, we need to multiply by how many 3s? We need 3 altogether. We've already got 1. We need 2 more. So 3 times 3 is 9. We've already got 1x, but in order to make a group of 3, we need how many more? 2 more, so that would be x squared. Do we all understand how I came up with the 9x squared? We need groups of 3 to be perfect cube roots. We already have 1 3. So to force there to be a group of 3 3s, I need 2 more 3s. 3 times 3 is 9. Does that make sense?
Yeah, what about the x squared?
Okay, we have 1x, but I need there to be a group of 3 x's. So I needed how many more?
2.
2 more. So x squared. Whatever we multiply to the denominator, we also multiply to the numerator. It's got to be the exact same thing, top and bottom. Now on this one, I will go ahead and write out the cube root on the top and the bottom for right now. In the top, we take 9 times 2, we get 18 x squared. And the denominator, we take 3 times 9, 27. X times x squared is x cubed. Okay, in the top, if we break up 18, I'll do it down here just to have a little space. Break up 18, what do you get? 9 and 2. 9 breaks into... Oh, hold on, we're looking for groups of 3. Do we have any groups of 3?
No.
So is the cube root of 18 going to simplify? No. So cube root 18 x squared. Do we have any groups of 3? No. So it's all got to stay under. So our whole numerator is staying exactly the same. Divided by, what is the cube root of 27? What is the cube root of 27? 3. 27 is a perfect cube number. What is the cube root of x cubed? Just an x. Okay, we could have a group of 3 3s, a group of 3 x's. Do we need a radical anymore? No, that is the whole point of rationalizing, is that we don't have a radical in the denominator anymore. So there's our answer. Nothing is going to simplify. Everything in our numerator is underneath a radical. And nothing in the denominator is under a radical. So nothing can simplify there. Any questions about number 9? Do we need more time copying it down before I bring back number 10?
How did you go from 9 to 18?
Because I had a 2 up here. Oh, this shouldn't be an equal sign. Sorry, that should be a big multiplication sign.
Oh, now.
That would make it a lot better. Does that clear it up?
Yeah.
Okay, good. Anything else? Okay. I'm going to take away some of this so that we can get number 10 back. There it is. If we do still need the answer, I'll write it down here for now. The answer to that one was the cube root of 18x squared all over 3x. All right, number 10. They've already got our square root split up for us. We could simplify by putting it back together, but not a whole lot, so there's no real point in going back and forth. So let's just start to rationalize it. With square roots, we like them because it's easy to know what's going to make it be a perfect square. 10xy. 10xy. Square root of 10xy times the square root of 10xy will force it to be a perfect square in the denominator. If I multiply it on the bottom, I have to multiply y the top on the same exact thing. 10xy. So in my numerator, I'm going to have the square root of what? 20. X to the fourth.
Yeah.
Okay, x to the fourth, y. Okay, so 2 times 10, x cubed times x. The y didn't have anything to multiply to, so it stays. In the denominator, what am I going to have?
100x cubed y cubed mean squared.
Good, 100x squared y squared. Still taking the square root, top and bottom. The bottom is going to be the easier one to simplify. What's the square root of 100? Square root of x squared. Square root of y squared. Okay, in the top, we have to simplify the square root of 20. Does anybody know what it will be? 2 root 5, good. And I'll leave a little bit of space. What's the square root of x to the fourth? X squared. You'd have 2 groups of 2, right? None left over. What about that y? Stays under. Doesn't have any pairs or friends, so it has to stay put. Now, last step, we look at what's outside of the radical. Can any of that simplify? Yeah. Good. The 2 over 10 simplifies to be what? 1/5. Okay, x squared over x. Leaves us with an x in the top. And then nothing to simplify with that y. Anything under the radical is staying underneath. So x root 5y over 5y. That's our answer. Questions about 10? Easy peasy? No. Not easy peasy? Number 11 should be easy peasy. Let's do number 11. Will 7 over 5 simplify as a fraction? No. So split it up. Square root of 7 over the square root of 5. What do I need to multiply my denominator by to make it a perfect square root?
5.
The square root of 5. If I multiply by that in the denominator, I have to also multiply by it in the numerator. In my numerator, I would have the square root of 35. In my denominator, the square root of 25. What's the square root of 25? Will the square root of 35 simplify? No, it just breaks back into a 7 and a 5. And we've already talked about we cannot simplify these if one of them's under a radical and one of them is not. So we'll leave it alone. Kind of feel like they should have started with number 11. It's one of the easier ones. Are we ready for number 12? On number 12, let's just go ahead and start rationalizing. This time we've got a cube root, so we need to force it to have groups of 3. We start off with 1 6. How many more do I need?
3.
How many more do I need? 2. I got 1. I'm going to need 2 more. So 6 times 6 is 36. If you'd rather write it as 6 squared, you can do that. I think that might confuse some people, but if you want to go that route, you can. Okay. We already have 1x. How many more do we need to make a group of 3? 2 of them. So x squared. We understand how I built what's on the denominator. If I multiply by that in the denominator, I also need to multiply by that in the numerator. Cube root 36 x squared. Now I'm going to take away number 11 so I can start writing my work over there. Got no room over here. So when I multiply the cube root of 4 times the cube root of 36x squared, you can multiply these together, or you can do like we were doing in the beginning of class and write them separately. 4 times 36 times x squared over what's going to be in my denominator. What do you mean by the same thing?
6 times 36.
So what is 6 times 36? Well, okay, so we can leave it like that. 6 times 36. If you want to leave it there, that's fine. Times x to the third. Okay, if we are breaking up 4 and 36, let's do that up here. 4 is going to break into 2 and 2. 36 breaks into 6 breaks into 3 and 2. 6 breaks into 2 and 3. 3 and 2. We're looking for groups of 3. What do we have a group of 3 of? 2's. What does not form a group of 3? One of the 2's and both of the 3's. So, in our numerator, we have the 2 coming outside. Cube root of what's staying in?
Oh, 3 and 2.
3 times 3 times 2 is 18. Can the x squared be broken into groups of 3? No. So the x squared is staying inside. Divided by. You could break the 6 apart, but you don't have to, because 36 breaks into 2 6's. So you have a group of 3 6's. Does that make sense? Are we okay with this group of 3 6's here?
Yeah.
Okay, so a 6 can come out. What's the cube root of x cubed? X. Notice that our denominator ends up being what was under the original radical. We forced that to happen. That's how it should work every time. Our last step is to see if something can simplify here. 2 over 6 becomes 1/3. So in the denominator, we end up with a 3x. In the numerator, we have the cube root of 18x squared. If you want to put the 1 out in front of your root, you can, but you do not have to.